Hai, Assalamualaikum. Okay, we continue. Okay, revision for SPM Physics, Kssm. So tonight I will continue with section A, number 6 to number 8, and then section B and section C. For trial SPM 2021 SPP. Okay, if you have the question, you can refer to the question. Okay, I have discussed number 1 to number 5. So tonight I discuss from number 6 to number 8 for section E. So look at number 6. Okay, diagram 6 shows a multi-tap transformer. Apa maksud multi-tap? Okay, you boleh nampak connection ya. Point of connection more than one. So you have point D, E, F. So if you want to change the number of turns for the secondary coil, so you can tap to DE or to DF or to EF. So you will have a different number of turns for secondary coil. Itu maksudnya multi-tap boleh ubah tempat untuk disambung tu. Okay, bila you sambung tempat yang berbeza, maka bilangan turns dia adalah berbeza. Okay, soalan. The given information for the primary coil, number of turns is NP 1000. And then the input voltage 240 volt. For secondary coil, if you connect to terminal D and E, the number of turns is 200. The output voltage 48 volt. Output voltage across secondary coil 60 volt. Okay, what is number of turns of secondary coil from E to F, and then the voltage across EF. Okay, later we'll discuss how to calculate that. Okay, what is type of transformer shown? How to know whether it's the step-up transformer or step-down transformer? You look at the input voltage and the output voltage. Okay, you can see from here. Okay, for the primary coil, 240 volt. For secondary coil is smaller, 60 volt. So it means step-down transformer. There are two types of transformers, step-down or step-up transformer. So in this case, step-down transformer. Okay. B, determine the values of NEF and VEF in table 6. So you have point for you all to tap. There are 3 tabs here. F. Okay, for DE here is 200 turns. For EF, let's say I put as Y. because I don't know the number. So the number of turns for secondary coil, we have Ns equals to 200 plus Y. Okay. Okay, using the formula Vs over Vp equals to Ns over Np. Okay, we just substitute the value. Vs 60, Vp 240, Ns 200 plus Y, and then the Np is 1000. Okay, 140. Okay, so from here we get 800 plus 4y equals to 1000. Plus we get 4y is 200 and y equals to 50. So y or EF and EF equals to 50 hertz. Okay, so what is VEF? Let's say you connect to the terminal of E and F, number of turns is 50. Now you want to find V. Okay, so I write in here, not enough space. So again, we apply VS, VP. We have VEF and EF. Okay, so sorry, there's a mistake here. VP, VP. VP lah ya, sebab kita gunakan ini sebagai VS. Okay, 250 over 1000. VEF, we want to calculate, and then 50 times. Okay, so VEF, you know, so, okay, and write in the table here the answer. And EF is 50, EF is 12. So its copper equals to 60. Okay. Okay, compare NP, NDE, and NEF. Guys, you know for NP, NP for is 1000, NDE is 200, NEF 50. So you can say NP is larger than NDE, larger than NDE. Okay. Compare the ratio of VP to VS with the ratio of NP to NDF. Equal the ratio is equal. Should be same because as we know V directly proportional to N. That's the reason why we get Vp over Np equals to Vs over Vs. Okay, apply the concept of electromagnetic induction. The more the number of turns, more the flux line being cut, so the higher the voltage induced in the secondary coil. We compare Vp, VDE and NEF. So we have Vp more than VDE more than VDF because directly proportional V and N. Okay. Based on your answer, state relationship between number of turns of coil and value of voltage. The larger the number of turns, the larger the value of voltage. Okay. Lagi banyak number of turns, lagi tinggi voltage dihasilkan. If the power supply in primary coil replaced with DC, state the value of current flow in secondary coil. No current flows. Or you can say that the current is zero. Okay. Okay, that's number 6. Let's look at number 7. Diagram 7 shows athletes spinning a hammer in a hammer throw sport event. I think you observed this picture in the textbook. So means the hammer will rotate in a circle. Okay, motion in a circle. The centripetal force acting on the hammer when rotated is the tension of the string. What is centripetal force? Okay, so the centripetal force is this one. Okay, there's a gravitational force equals to centripetal force. To definition, what is centripetal force? A force that force Okay, we look at again definition for centripetal force. A force that causes an object to follow a circular path. Okay, object that moves in a circular path, there is a centripetal force. Which direction is always in the is always towards the center of the curvature. Okay, so means as this case, so this is the center of curvature. Center of curvature. So means it will move in circle. Okay, move in circle. Okay, diagram 7, mark direction of centripetal force acting on the hammer. So you just mark for centripetal force. So I rub off another symbol here. So this one, yeah, centripetal force. Okay, part C. The hammer of mass 4 kilogram, given mass and 4 kilogram, rotated in horizontal circle, radius 1.6 meter, linear speed 25. Calculate centripetal force acting on the hammer. So you can remember the formula, or you can just go and check the list. Formula for centripetal force, F equals to mv squared divided by r. Okay, mass in kilogram for D is 25, right, divided by R, 1.6. Okay, use calculator to calculate. You should get the answer as 1562.5 Newton. So the unit is Newton. Unit must be correct. Yeah? Okay, table 7 shows characteristic of FGH hammer throws involved in the hammer throw sport event. We have FGHL, length of steel 1.85, linear speed is rotated. So the length of steel string actually represent the value of R. Because when rotate, the radius of the curvature is equals to length of the steel string. And then this one is linear speed. Based on the specification, state suitable characteristic of hammer throw that has highest rope tension. When it is rotated, give reason for the suitability for each of the characteristics. Highest rope tension means higher centripetal force or larger centripetal force. The factor that affects centripetal force is mass, B, and R. So in this case, they have same mass. All the hammers of same mass. Okay, just the difference in length of string and linear speed. Okay, for length of steel string, F equals to mv squared divided by r. Okay, to increase F. So the value of r must be shorter. Okay, so you can just write down shorter lengths of steel spring. Shorter length steel spring. Okay, shorter. Give reason. Okay, larger centripetal force. Okay, linear speed of the hammer. You can see the relationship directly proportional to v squared. F means larger linear speed. Okay, reason, you can repeat the reason. Larger centripetal force or larger centripetal acceleration. So it will move faster and further. Okay, move faster and further. Okay, so you have this formula. I hope you know this formula for centripetal force. So when you answer, you can just refer to the relationship between F and R and F and V to get the answer. Okay. So what is centripetal acceleration? So you can relate this one to uh, Newton's second law. So we get ma equals to mv squared divided by r. So you can cancel m. So you get a equals to v squared over r, also known as centripetal acceleration. Okay, so means accelerate faster and move further. Okay, so this is the which one we should choose. You can refer again to the table. Short one, short. So I think this one. And then the linear speed, the highest one. So we should choose H. Okay, so you write down the answer here, H. Okay, number 8. Diagram 8.1 shows an airplane and it is a cabin altitude which is 2134 meter, and when it is a cruise altitude 10973. At cabin altitude, pressure 77.9 and equals to atmospheric pressure at equivalent altitude. Atmospheric pressure drops to as low as at altitude of 10973. So you can see all about change in altitude. What is this altitude? Means height, ketinggian. Okay, and also discuss about pressure. So the change in height will cause the value of atmospheric pressure change. From the formula P equals to H rho G. Atmospheric pressure is equals to weight of air above the point. Okay, so means it depends on the density of air. As we go up to higher places, density of air becomes smaller. So that's the reason why atmospheric pressure decreases with height. Okay, so the higher the height, the smaller the atmospheric pressure. So what is definition for atmospheric pressure? Okay, it is the pressure due to weight. Weight of air in atmospheric layer. Okay, okay. E. How might the human's rates of breathing change at high altitude? Explain your answer. Okay, bila naik tinggi tu, you can see density of air decrease. So the rate of breathing will increase because try to capture more air into the lung. Okay, so need more air. That's why need to breathe harder. Okay, so the rate increase. Reason. Okay, so rate of breathing increase because density of air decrease at higher altitude. Okay, dia macam tercungap-cungap sebab tak cukup udara. Macam tu lah. You can see most commercial jets use air that enters jet engine to provide air to cabin during flights. The air is then processed, cooled, and finally piped into cabin. The pressure in the cabin is kept under 75.8 kilopascal and 82.7 kilopascal to ensure that passengers and flight crews can breathe easily. Okay. So what is the method that can be done to ensure that passengers of airplane get enough air at high altitude? So means that we need to have more supply of air. Okay. Okay, so macam mana nak hasilkan ataupun nak bawa masuk lebih air. Kalau aeroplane ataupun engine jet, the air is sucked into the combustion chamber for combustion of the fuel, for example. So means we need to absorb more air into the engine, okay, into the combustion chamber. So for example, the answer you can write as to increase the rate of absorption of air through the engine. Okay, the engine absorbs more air. Okay, reason to increase the air supply. In the cabin. Okay, nak menambahkan jumlah udara supaya tak ada sesak nafas. Rate of breathing will increase if not enough air. Okay. Okay, suggest action to be taken if there is passenger suffering from a lack of oxygen absorption in his lung during the flight. Yeah, kalau macam ni macam mana? Suddenly there's a drop in air in the cabin. So maybe there's some passengers will experience something like this, suffering from a lack of oxygen absorption. Okay, so normally there is the oxygen mask placed somewhere near to the seat of the passenger. So the person or the passenger can use oxygen mask. Okay, ini guna topeng oksigen. Reason. Okay. Because for breathing we need oxygen. Okay. Okay, part 3, diagram 8.3 shows a side view of airplane window design proposal. Pick the correct design of the window to create a safe pressure difference between air inside and outside the airplane. Which one? Okay, this one we need to look at the shape. Which one is suitable? Either the flat one or the curved one. Okay, this is inside, this is outside. So for this case, we will choose the one which is curved. What is the reason? When curved, okay, the wind or the air blows, it will create very low with pressure region outside, and the pressure inside, which is higher, will push, okay, outwards. Means the surface will not be uh, damaged by difference in pressure from outside. That one will cause injury to the passenger. So design of window to resist deformation caused by extreme difference in pressure. Okay, that producing greater force acting from inside of the airplane compared to force from outside. Okay, so not easily deformed the shape. Okay, that's why we choose this one. Okay, justification. Okay, the windows. Then the wall of the plane not easily deformed due to the shape. Okay. Okay, why not easily deformed? As the force acts from inside. Okay, okay, not outside. From inside to outside. Okay, so it produces a greater force acting from inside on the airplane compared to force from outside. Okay, so it will maintain the shape. It does not cause the plane, the wall of the plane to deform. Okay, okay, that one is for section A. Now we look at for section B, number 9. Okay, diagram 9.1 shows a cooling curve of gas sample 160 degrees Celsius, cool for 25 minutes. Okay, ini cooling curve. Define latent heat of fusion. Okay, amount of heat required to change a phase of a substance. Okay, or to change solid to liquid or liquid to solid at constant temperature. Okay, you can write in the the paper given to you, the foolscap paper. Okay, so I have finished for section A. I think for section B, I will continue in my next video because of some problems. Okay, so I think for today that's all because I already spent about 40 minutes. So I will continue with section B and C in my next session. Yeah, thank you for those online with me. Bye.